Hi, my name is Nicholas Maiden. I'm a manager within the engineering division. I oversee the section that handles the permitting of the majority of engine applications as well as material handling. And I'll hand it over to Carol.
Hi, I'm Carol Allen. I'm also a manager in the engineering division, and my section handles the health risk assessments for the division for new and modified projects.
Hi, I'm Fred Tanaka. I'm another manager in the engineering division. I'm in the technology implementation, operations, and permitting section. And my section supports a lot of the division activities.
So I'll take it from there. Thank you everyone for attending. We've got, as you can see, a packed agenda. We'll kind of discuss background on the Air District, mission, engineering activities, and then delve into some engine statistics, the regulations that establish what's called best available control technology or BACT, and then BACT for toxics, what we've determined for achieved in practice, EPA Tier 4 standards, availability of these engines, and then some of the requirements and advantages of installing certain configurations, and then what folks can do to have a faster permit, and then at the end, an FAQ and some questions and answers period. So the Air District mission, we're actually undergoing a strategic plan development now, and we crafting this mission, but currently our mission is to protect and improve public health, air quality, and the global climate. Our Air District was established in 1955, covers 9 counties of Bay Area, about 7 million residents, 5 million vehicles, and about a little over 5,000 square miles. So what does the engineering division itself do? We issue what's called a permit for over 10,000 facilities. So we get about 1,200 or so applications per year. That varies depending on market and other factors. But a good portion of that, 400 or so, are engine applications. And we conduct about 300 health risk assessments per year. We issue several different kind of permits. Authority to construct, which allows you to construct equipment or install equipment. What's called a permit to operate, which allows you to permit or to operate equipment. And then a registration if don't need a authority to construct or permit to operate, and then a certificate exemption if you choose to get one from us. We also maintain an emissions inventory, and we issue and maintain federal operating permits. So here's some statistics about the engines that we have. We've permitted about close to 11,000 internal combustion engines. The bulk of those are diesel emergency backup engines, and of those, majority are between 50 horsepower and less than 1,000 horsepower. That's what we call small to medium-sized engines. Anything larger than 1,000 horsepower was covered by a previous BACT determination and webinar. So what is BACT? We have a couple regulations that govern it. Regulation 2, Rule 2 is our new source review rule. It applies to new or modified sources of air pollution. And there's a requirement that if you have what's called the potential to emit more than 10 pounds per day of a pollutant, you'll require best available control technology. And for emergency generators in particular, it's based off of 24-hour operation. It doesn't distinguish between planned or emergency operation. So even though you may have an engine that's intended to only operate in emergencies and maybe operate up to 50 hours per year maintenance, will still trigger the BACT triggers based off of that 24 hours. And then we have a second regulation. This covers the best available control technology for toxics regulation. This implements new source review of toxic air contaminants. It's Regulation 2, Rule 5. In addition to TBACT, it has a health risk assessment requirement. And the BACT for criteria pollutants is based off of criteria pollutants, emission 10 pounds per day of emissions. TBACT is based off of a health risk. So if a source has a cancer risk greater than 1 in a million and or a chronic hazard index greater than 0.2, it'll require TBACT. And we have some definitions of what a source risk and cancer risk is here. It's defined in the regulation. So what is BACT? How do you establish it? There's similar definitions in both regulations, but there's a little caveat. Both require BACT and TBACT look at what's most stringent, either achieved in practice. So if another facility has put something that's better performing and there's an emission limit and it's been demonstrated through source testing and other means to meet that limit, then that could be deemed what we call achieved in practice. There's something called technologically feasible or cost effective for BACT, where if there's something more stringent than what's been deemed achieved in practice, it's technically feasible for that particular source category, and what's cost effective, so it's dollar per ton of emissions reduced, is below a certain threshold, then we'll require that. The difference between TBACT and BACT in terms of technologically feasible and cost consideration is BACT has a specific cost effectiveness threshold, and for TBACT we consider cost, but there isn't that threshold. We also publish what's called a BACT TBACT guidelines on our website. This compiles what determinations we made for a variety of source categories, what's been deemed achieved in practice, what's been deemed technically feasible and cost effective. And we put that up on our website for kind of a useful starting point. So applicants can look at that, consultants can look at that and see at least what minimum requirements they would need to meet, minimum emission thresholds. But doesn't supersede the regulation. So if something else has been achieved in practice that's more stringent than what's listed in that guidelines, then you may be subject to that. If you have something that's more, there's something we deemed cost effective or technologically feasible, then you may be required to do that as well. So for these small to medium-sized emergency generators, we're making a new achieved in practice determination. We reviewed a variety of information sources, our own issued permits to operate, the EPA RAC-backed layer clearinghouse. That's a compendium of determinations throughout the United States, as well as other air districts. And after that review, what we found is that achieved in practice for emergency diesel internal combustion engines less than 1,000 horsepower, EPA Tier 4 final certification values has been deemed achieved in practice, and that's based off of, we've got over 35 plus permits to operate, a couple clearinghouse determinations, and there's actually some other air districts that are already implementing this in their jurisdictions. So what are the EPA Tier 4 emission standards? This is from a federal regulation. They listed in based off of the engine power, maximum engine power, and they have it in units of grams per kilowatt hour. We've gone ahead and converted that to grams per brake horsepower hour. And so they have 4 different pollutants, what's called non-methane hydrocarbons, oxides of nitrogen, NOx, carbon monoxide, and particulate matter. And so after this webinar, we'll go ahead and post this to our BACT workbook, so for future reference for applicants. One of the things that were concerned us with, particularly these generators, is if they're available, because as we saw on the statistics slides, there's a large number of applicants and facilities that have these installed. So we want to make sure that these Tier 4 engines that are certified through EPA are available. And so we reviewed a database that EPA publishes of engine models and manufacturers and different size engines that have been certified to meet Tier 4 emission values. And so we concluded that there are a significant number of available models, that this wouldn't be a limiting factor for applicants going forward. So how may an applicant comply with the Tier 4 emission standards? The first way is purchasing or installing a certified Tier 4 engine. This is certified by EPA to meet Tier 4 standards, and there's a process that they have to go through. They source test, they review emission limits. There's some requirements these engines have to meet, and some features they have to have installed to be able to be certified. The second option is to have what's called a compliant Tier 4 engine. So this is an engine that's packaged by the same manufacturer with manufacturer abatement equipment with identical or near identical components as a certified Tier 4. It just hadn't gone through their certification process, and it doesn't have some of the features that EPA requires for a certified Tier 4 engine. The final way is to install what's called a retrofit Tier 4 engine. This is where an applicant may have a lower tiered engine, Tier 1, Tier 2, Tier 3 engine, and they add third-party equipment from a third-party vendor. So abatement equipment that's not necessarily made by the engine manufacturer. Because this is not made by the same manufacturer, there may be more requirements imposed because there's less certainty that it will meet these Tier 4 standards. So what are the advantages of getting a Tier 4 engine? Like I mentioned, they'll have the least restrictions. If you go through a retrofit, it'll have the most restrictions. So these are proposed requirements. If an applicant comes in with a certified Tier 4 engine, they'll have no usage restrictions other than what's limited by our engine rule, which is Regulation 9, Rule 8, covers NOx and carbon monoxide. So that typically states that you have your emergency use is unlimited, and your non-emergency use for maintenance and testing is limited to 50 hours per year if you're not what's called an essential public service defined in the rule, or 100 hours per year if you are. And then they'll have no testing requirements. So we're not going to require a startup source test, which is typically required for equipment that trigger backed or T-backed. However, if you put in a compliant Tier 4 engine, you'll similarly won't have any usage restrictions. But if you trigger T-backed and you use something other than a California Air Resources Board verified diesel particulate filter to meet that PM emission limit, then we'll require a source test for PM, and then while you're testing for PM, we'll also require for NOx and CO. So if this engine is meeting a PM limit through diesel oxidation catalyst, SCR, engine modifications, anything, or a non-CARB verified DPF, then you'll require a source test. If you're not required to source test, then we'll proposing to require testing NOx and CO with the portable analyzer during your maintenance testing to make sure that it's in line with how the engine should be running. And then one benefit with a compliant Tier 4 engine is we will allow pooled testing. So if an engine manufacturer has a package of compliant Tier 4 engines, and they can come to us with source test results, and we may review that, and if approved, to use that in lieu of each specific installation having a source test. And then finally, the most restrictive will be retrofit Tier 4 engines. If there is a retrofit of a Tier 4, regardless with abatement or not abatement, or if you're retrofitting a Tier 2, Tier 3 without abatement, so you're taking a Tier 2 engine and doing engine modifications to meet the Tier 4 standards, we're proposing to have usage restrictions and a required source test. If you're retrofitting a Tier 2 or Tier 3 with abatement, then there'll be usage restrictions unless you're doing a source test. And it'll be similar to a compliant test in that if you're using something other than a CARB verified DPF to meet PM standard, then we'll require a source test, and then as well as NOx and CO. If you have a CARB verified DPF, so you don't require to use not required to source test for PM, then you'll use a portable analyzer for NOx and CO. And in this case, pool testing won't be allowed. And for the NOx and CO, the results of the portable analyzer will be used to determine whether a source test is needed. If the analyzer results indicate there's an issue with the engine, it's not meeting the Tier 4 standards, and then there's some tuning or something needs to be done, then we'll have also a source test requirement. So this is a question we get a lot, especially in my group. I think the last month I've had about half a dozen applicants come in with an application and say, hey, I need this engine in 3 weeks, or I need it in a month. Clearly that's, I don't know if we can't meet that, regardless of the configuration, but there are things that applicants can do for faster permitting. First one is come in with a certified Tier 4. So if applicants come in with a certified Tier 4, they have less restrictions and it'll lead to faster permit processing. If an applicant has the option, what we would suggest is selecting the engine size and or hours of use that would not trigger a health risk assessment. That's the best case, or not trigger what's called a refined health risk assessment. If you trigger a health risk assessment, those are done by Carroll's group, and they're specialized folks with specialized equipment, and they're not, it can lead to constraint in terms of the processing time, depending on the number of applications that require health risk assessment and the workload. So if you can avoid having to do a health risk assessment, that will lead to faster permitting. If you submit a complete permit application, please submit it through MyAirOnline. We do get them through emails and snail mail. Our operations staff, Fred's staff, have to review that and work with the applicant. Sometimes there's an issue with the scanned files. Sometimes there's an issue with the mail, and that can lead to delays. So if you submit it through MyAirOnline, it'll reduce that time for processing for when we create an application. If an engine is within 1,000 feet of a K through 12 school, and with more than 12 students, it will trigger what's called a public notice. And that can lead to delays because we have to work with each school district, and we're up to each school district's resources and timing. So that could be 2 to 4 weeks just to get a list of the addresses of the guardians of those students in which we can send the public notice. Once we get that list, it takes 30 days minimum for public notice, and then we have to review and respond to public comments accordingly. So triggering a public notice will add time. If an engine is within what's called an overburdened community, or OBC, it will trigger public notice if a health risk assessment is triggered, either streamlined or refined as required. So that gets to the second bullet. If an applicant select their engine size or the hours of use to not trigger a health risk assessment, then that won't trigger a public notice if the engine's located within OBC. And with that, I'll hand it over to Carol, who will discuss streamlining.
Okay. So as Nick mentioned, there are we've developed there's 2 screening criteria for determining whether or not a health risk assessment is required. The first criteria is in our Regulation 2, Rule 5. We have a table of emission rates, acute and chronic emission rates that trigger a health risk assessment for individual compounds. For diesel engines, we use the diesel particulate matter as a surrogate for all of the toxic compounds. And there is a health risk assessment requirement if emissions for a project exceed 0.26 pounds per year. This obviously is very low emission rate, and almost all Tier 3 engines required that. However, with the Tier 4 engines, because they are emitting such a lower rate of diesel particulate matter, there are opportunities to accept for certain engine sizes and for certain projects where you can limit your hours of operation for non-emergency operation for reliability related testing that would enable you to avoid that health risk assessment requirement. So this would save you considerable time by not having to go through that requirement. And also you would, if you're in an overburdened community, if your facility is located within an overburdened community, then you could avoid having to go through a public notice unless you're still located near a school. So those two would save you the most time during a permit application process. And then, so what we've done here is prepared a matrix of distances from your project to the nearest receptor on the top, and the engine size on the left, showing the hours of operation that would, in green, that would avoid the health risk assessment. For larger engine sizes, that may not be possible to avoid the health risk assessment requirement altogether, but we do have streamlining criteria that would enable us to process the health risk assessment for that operation much more quickly. These streamlining criteria use very conservative assumptions to determine what sizes of engines would still meet our permitting thresholds, or project risk permitting thresholds, if they are, if you stay below these hours of operation. And then finally, in the brown, the larger size engines especially those that are located less than 300 feet from a receptor, will require the refined health risk assessment. And we do have, if you have more than one engine in a project, you can apply the total project size. So for example, if you had 200 horsepower engines, you could look at what the criteria is for a 200 horsepower engine and determine that, okay, if I'm less than 100 feet, then I need to stay below 25 hours of operation for both of those engines in order to avoid triggering a health risk assessment requirement. So we wanted to publish this table to help you choose what you can do for your project, so you can come in with a project that you know is going to either qualify for no health risk assessment or a streamlined health risk assessment where possible. Next slide.
So this is our FAQs. One question I'm sure you're asking is, does this apply to you, or does this apply to applications in-house? If you have an application in-house or you submit one before December 2nd, this won't apply. We're going to like I mentioned earlier, upload this determination to our backed workbook, and we'll have it effective December 2nd and for any applications going forward. If you determine that you have an engine that doesn't meet Tier 4 and you'll be subject to it, what you can do is work with your engine vendor or consultant to come up with a Tier 4 engine option, either certified, compliant, or retrofit. If you have an authority to construct that's already been issued, there are some requirements. If you go ahead and install the equipment authority to construct prior to expiration, you can go ahead. You're not going to be subject to this new back standard. But if you renew it, we'll have to look at what has been deemed back, and then at that point you may be subject to this determination. So if you have an authority to construct, I would suggest go ahead and availing yourself of that if you can prior to expiration. If you have to withdraw your application, and this is for any permit application, we do refund a certain portion of that, and that's covered in our Regulation 3, our fee rule. And then you can apply that if you submit a new application for the same project within a certain time period. So one question that comes up frequently, not just for engines, but for anyone, they find our BACT workbook or BACT guidelines on our website, and they ask, their equipment meets that, what's standard in that BACT workbook, and they figure that they meet BACT or TBACT. And as I mentioned earlier, the guidelines are really just as a starting point. They don't supersede the regulation. So the BACT and TBACT is made on a case-by-case basis at the time an application is deemed complete. So if equipment comes in meeting the BACT workbook, it may or may not meet BACT. It depends if if nothing more stringent has been deemed achieved in practice or technologically feasible and cost effective. This question has come up heard this from some stakeholders in other air districts where certain industries have said they're not allowed to install a certified Tier 4 engine, and they pointed to this NFPA regulation 110, and there's actually an amendment that was just passed where the language specifically states where used for permanent level 1 applications, EPA mandated inducement engine shutdowns due to emissions system controls that are required on Tier 4 certified engines with SCR shall be prohibited. And what this is referring to is one of the requirements for EPA's certification for Tier 4 is that if you have an engine that uses a selective catalytic reduction, SCR, that uses a reductant other than the fuel, so it uses diesel exhaust fluid, urea, that the engine has certain features to determine whether the quality of that DEF is good. Does it meet the SCR specs? Is there actually enough DEF in there? So if the level gets too low, there's some warnings, and that the engine actually derates the power, and then eventually shuts off after so many warnings. And what certain stakeholders have expressed concerns about is that if in life-saving or essential applications, you can have an engine that's an emergency shutdown simply due to inducement. And so the NFPA came out with this requirement that you can't have these inducements at level 1. However, in the EPA regulation, there's actually an allowance for this. And the 2 committee members, when they discussed that amendment, actually pointed out this. One said that the disabling of the inducement shutdowns to be used in cases of level 1 is permitted by the federal regulation that has the certification requirements. And so the EPA regulation, like I mentioned, federal regulation has this requirement to have what's called these inducements, where there's an SCR used to meet the NOx standard of Tier 4. However, the regulation also allows that engine manufacturers the engines can have what's called an auxiliary emissions control device, or AECD, installed. And what this AECD allows is that you can temporarily disable the emission controls, the inducements, during a qualified emergency, so a situation which is defined as a direct or indirect risk to human life. And if with this override, engines can operate up to 120 hours, so 5 days per use, without the inducements. That's a one-time use code. After that, they'll need the temporary code from the manufacturer or input from a qualified service technician or a security feature to be able to reset the override. And that NFPA 110 amendment actually applies to what's called level 1 installation. And so that code, NFPA 110, actually has 2 levels. And so you say level 1 is where failure of equipment could result in loss of human life or serious injuries. And level 2 is where failure is less critical to human life and safety. And they give examples of in both. So level 1, if you have an elevator, a fire pump, fire detection, life safety illumination, emergency services communication system, so like 911, essential ventilating and smoke removal systems, medical life sustaining systems. And level 2 is heating and refrigeration systems, communication systems other than emergency services, communication services, industrial processes, and water and wastewater treatment systems. And then standby generators used solely for telecommunication services to meet FCC guidelines are classified other than level 1 or level 2. One thing we've heard from stakeholders is they say, hey, I'm an essential public service, which is defined in our engine rule. It's defined in section 98233 as a sewage treatment facility and associated collection system, water treatment delivery operations, public transit, police or firefighting facility, airport one-way lights, or hospital or other medical emergency facility. And the distinction between essential public service and Regulation 9 Rule 8 and not is how many hours of maintenance and testing you're allowed. So Regulation 9.8 allows essential public services, emergency generators, to have up to 100 hours per year of testing and maintenance. Everyone else is limited to 50 hours per year. And you can see there's a difference between the definition of level 1, level 2 in FPA and Regulation 9 Rule 8. And so we listed some scenarios where you may be subject to that NFPA 110 amendment regarding the inducements. So the first scenario, your emergency standby generator or wastewater treatment plant. The way we interpret it is you're not subject to that section 5.6.5.5.1. You wouldn't need a certified Tier 4 engine if you were to install one with an auxiliary emissions control device. You can install any certified Tier 4 engine and still be in compliance with NFPA 110. The second scenario is you're generating at a hospital, but you're only powering office lights, not powering any life-sustaining equipment. Similarly to the first scenario, you can install any certified Tier 4. You wouldn't need an AACD. In the last scenario, you're a generator at a hospital where you are powering life-sustaining equipment. That's where that NFPA amendment would apply. And in this case, if you were to choose a certified Tier 4 with an SCR, then you will need to have that AACD to be able to meet the NFPA. We've seen and heard from some engine manufacturers, and not every engine manufacturer or uses an SCR to meet the Tier 4 NOx. So if there are certified Tier 4 that may be available in these scenarios for emergency generators like hospital or other areas where it is critical to human health. So the question can be that does this mean that BACT or TBACT is certified Tier 4? No. As I mentioned, you can have a retrofit or a compliant Tier 4. However, the certified allows this inducements, requires the inducements, and the intention behind that is that the engine won't operate. There are restrictions on operating the engine without required emissions controls. Similar to all our equipment that requires BACT, TBACT, that uses abatement to meet BACT or TBACT, we have a permit condition requirement that says you have to abate at all times, including emergencies. And so if an engine is operated without emission controls, the owner operator would be in violation of that permit condition. What we're also proposing is that if you come in with a compliant or retrofit engine, there will be requirements to identify and track some features that will let us identify when an engine is operated without emission controls. So the alarm data loggers and some other features that'll alert us that an engine was operated without the controls. And that owner operator, unless they obtain what's called a variance or an emergency variance from our Air District Hearing Board, or they obtain breakdown relief, and that's with our Compliance and Enforcement Division, then they will be in violation of the permit. So that the other advantage to coming with a certified Tier 4, in addition to faster processing, less restrictions, is there's less enforcement risk, less parameters and things you'll be held to and are required to track, because with the inducement features, it'll hopefully prevent operating the engine in a non-compliant situation. With that, we'll go ahead and have a question and answer period.
Okay, we already have quite a few. A lot of them are, I'll just clarify, if you have an application in-house, we are still continuing to work on it with current BACT. So this will apply to the small and medium engines that submit applications on or after December 2nd. And then, let's see. I'll start at the top and then switch off with Carol. Carol, if you want to look at the ones in the chat, but I'll switch off. In what situation will a retrofit Tier 4 engine not have abatement? The first two sub-bullets. So I think this was you're referring to your slide with the certified on the left. Or this, yeah, certified on the left, compliant in the middle. Yeah, this one. Or the next one, yeah, this one. And if anybody wants to come off mute to clarify their questions, you can just raise your hand and we can unmute you.
Yeah, this is where we've seen that there are some, it appears from EPA's database, certified Tier 4 engines, that there are engines that through exhaust gas recirculation, through engine modification, can meet Tier 4 standards. And so this Tier 2, Tier 3 abatement is the case where an engine manufacturer may take a Tier 2, Tier 3 engine and then through engine modifications alone meet Tier 4. And the reason why we're making a distinction between engine modifications and CARB verified DPF is that there's more uncertainty with engine modifications that they can meet the emission standards. Whereas with the DPF, since you can add it on and we can see that verify the DPF is actually installed, that there isn't an issue with the DPF, there's a little more certainty with the emission levels. But if there's an engine manufacturer who'd like to correct us, they please do. Also, what we didn't mention is that if you afterwards, if you go ahead and submit comments or if you have feedback, we'll take those as well. Right here, we're trying to cover different scenarios because we are rolling this out. We may expect it will learn some things. We may find that there aren't a Tier 1 retrofit installations out there. There isn't a Tier 2, Tier 3 abatement, no abatement option out there. In which case we won't see those applications and these scenarios wouldn't apply.
Carol, do you have a question in the chat? Oh, you're on mute.
Yeah, I was going through the chat and answering several questions about receptors and receptor distances. So there was a question, can you clarify how you define a receptor for the streamlined HRA criteria? Is it just residential or sensitive receptors? So receptors are defined in Regulation 2, Rule 5. They include residential, worker, and student receptors. And residential workers may potentially be on site at a facility. So for example, if you are an applicant for an emergency generator for an apartment building or say a senior housing facility, those would have on-site receptors. And so those are definitely included in the receptors. Worker receptors are generally off-site worker receptors. But if you have a building where you're applying for an emergency generator for your operations in that building, but there are other facilities and other entities operating in that building and that are not associated with your facility and are not under your control, then those other facilities would be considered off-site worker receptors. And there was a question about how do you determine the distance? And the distance is from the exhaust point of the engine to that nearest receptor location. And that generally means the building in which the receptor is located for rather than like a parking lot. And
And
I think
Go
that
ahead.
was, oh, the last question was about the hours of operation. Limitations, and do they apply to emergency hours or only the reliability related testing hours? Those are reliability related maintenance and testing hours for that table there. Those are not emergency operation times. Emergency times are excluded from the health risk assessment.
I think, yeah, I saw another one. Someone asked, how can we apply for a permit? I think the same person asked in the Q&A, how can you check if their facility has a permit? I'm assuming it's their facility. If that's your facility, you can ask your contact to your permit engineer if you have a permit. On our website, under the permitting section, it has instructions on how to apply for a permit, or you can talk to your permit engineer. We also have a permit ombudsman that you can contact, and their email is also on our website. Let's see. Are all of the engines shown in the slide used in emergency generator applications? There are significant engineering costs for a UL 2200 listed and seismically certified, and showing all Tier 4 final listed engines is not an accurate representation of the units available for emergency standby applications. So I guess this is Nick, your list of the available models.
I believe they're referring to the 35 plus, or are they referring to the availability? What I will say is the air district permits that we saw, Tier 4 engines, they ran a gamut. There were some at wastewater treatment plants, hospitals, different kind of facilities, a few like fire pump engines, standby generators. I don't recall all of them. I'm not familiar with the UL requirement.
Okay, so if you have more to clarify, if that didn't answer the question, you can always email us with more detail. Thanks. Okay, does this affect hospitals? And yes, these would affect hospitals. What date will BACT take effect? Again, that's for applications submitted December 2nd or after. Okay, I don't know, Carol, how do you determine sizing an engine in hours not to trigger an HRA? I think that's just all on the table. I don't know if anybody has their hand raised and wants to clarify that, or maybe just list it.
Yeah, these requirements here, if you notice, there's size ranges for the engine on the left where it says under the column engine capacity ranges. So this applies for, this table is set up really for a single engine application. So if you have, for example, a 350 horsepower engine, you would have your engine size range would be between 300 and 600 hours of operation. In order to avoid having a health risk assessment altogether, if your project is located within 100 feet of a receptor, then you would need to limit your non-emergency operating time to 13 hours per year. The both there is referring to both for projects located in overburdened communities and those that are outside of overburdened communities. If your distance was a little bit farther away and you had a project in an overburdened community, then you could qualify for health HRA streamlining, which would be a faster process than a refined HRA, but would still be subject to a public noticing requirement if you limited your hours of operation for that engine for non-emergency purposes to 21 hours per year. And then if you were even farther away from a receptor, say greater than 300 feet, then there would be no restrictions. You would be limited to the standard 50 hours per year for reliability-related testing that's in the regulatory requirements, and it would still qualify for HRA streamlining.
So if you're on the border between the green or blue, or the orange and green, orange and blue, this is where that slide stated if you can size the engine, if it's not available to you by a size. So instead of choosing a 775 horsepower engine within 300 feet, which would trigger refined HRA, you chose a 750 horsepower, or a 600. That would get you out of the refined health risk assessment into either a no health risk assessment or streamlined. And similarly, if you're up if you're between 100 and 175 or below, that can get you in or out of triggering health risk assessment. If you are putting a smaller engine, it doesn't trigger health risk assessment. And if you're in OBC, you wouldn't need that public notice. And so that not only do you save time on health risk assessment, you save time on the public noticing. That can cut out 3 to 5 months of time right there.
Okay. No, thanks, Nick. I'm going to try to cover some of these HRA questions. You might have answered it, so maybe you could just clarify it just to show how this might demonstrate how your table works. Why does being greater than 100 feet from the closest receptor require a streamlined HRA when being less than 100 feet does not?
So the blue is for a streamlined health risk assessment, and the green is for no health risk assessment. So why the difference between 100 feet and greater than 100 feet? It's because our modeling has demonstrated that for projects that are located within 100 feet, that the peak the peak impact area for these engines is generally within that 100-foot spacing. And if receptors are located farther away, that you you're given some credit for that distance. It drops off as the impact to the receptors drops off the farther you get away from that source. So that critical distance there is 100 feet. And so the green is for no health risk assessment at all. And it applies to these different engine size ranges. So for example, a 50 horsepower engine or 50 to 100 horsepower engines that are located less than 100 feet would not require any restrictions beyond the 50 hours. That's the standard allowable limit for reliability related testing, and they would not have to have a health risk assessment, but larger size engines would.
And where there's an overlap, like let's say 200 horsepower, we're not saying there's no health risk assessment. There's no health risk assessment if you're within 100 feet, only if you limit 25 hours per year. So the difference between no health risk assessment and streamlined is as the distance increases, you can have the usage increases. So if you were a 200 horsepower engine, you wouldn't trigger an HRA if you limited 25 hours. If you didn't limit 25 hours, then you would be subject to streamlined health risk assessment only if you limited to 43 hours per year if you're within an OBC. So that's interpreted to show the limits you need to meet to be able to trigger the no HRA streamlined or refined.
That's good. Will this HRA streamlining matrix be formalized in an engineering policy we can reference in the future for permit applications?
So the basis, the policy basis for the HRA streamlining is already in an internal policy. Pam would be posting the policy, or
We'll post the streamlining, and then yeah, we'll determine whether we need to post the policy too.
Well, that's a good segue. Like I said, I oversee this engine section. This webinar and this streamlining are just a couple of the tools we were looking at implementing to have faster processing and more efficient processing these engine permit applications. Some of the other things that we're considering are we're going to update our website to have some of these tools available to applicants ahead of time so they can go ahead and say, am I in an OBC? Would I trigger a public notice? What can I do for streamline? Do I trigger a health risk assessment? Do I meet back or not? And so we're looking to upload some version of different tools on our website and make it a little more navigable and easy to get to for applicants.
Is there any way a particular generator manufacturer and a compliant third-party SCR system with a proven track record based on previous source testing not have to source test, sort of like a verified system?
I assume they're talking about where they meet the PM standard with something other than a CARB verified DPF. If that engine manufacturer uses a CARB verified DPF to meet the PM, then you wouldn't need to test. Right now, if you're using third-party equipment and it's not CARB verified DPF, to meet the PM limit, we are requiring a source test. But if the engine manufacturer has some feedback or some things we may not have considered, please provide us after the webinar, and we'll review it.
On the emissions test pooling, is this on a site-by-site basis or the entire air district?
It was more on a engine package specific. So if a compliant engine for a model and abatement, it would apply for that particular model engine and that particular package of emission mitigation or techniques.
You might have answered this, Carol, let me know. Can you clarify how you define receptor for the streamlined HRA criteria, just residential or sensitive, or any receptor, including worker?
it would include any receptor, including those offsite workers that I mentioned earlier. So, and I just want to clarify, it's typically offsite. It could potentially be an on-site worker receptor if you have that case where you have multiple tenants in a building and you only have control over some of those tenants. So typically it's an off-site worker, or if it's a residential receptor, it could be an on-site residential receptor.
Okay, and they did add recreational. So recreational is usually hourly, right?
Yeah, we don't typically include things like a park, if that's what you mean by a recreational area. There are other situations in which we do consider a park, and it's when we are evaluating acute health risks. But this is very specific to diesel emergency or diesel fired equipment in general, is that the diesel PM does not have a health effects value for acute. And so we don't look at acute health risks for these diesel-fired emergency generators. But there are other situations where we would look at a recreational area such as a park for acute health impacts, but not for diesel PM in particular.
Okay, thanks. Someone asked for stormwater pump stations that are currently in process of being built. Does that count prior to December 2nd, 2024? So that depends. Does it have an authority to construct? So do you have a permit for that? So anything that has an AC or is already in-house being evaluated is not subject to the new standard. It would be on applications new submitted on December 2nd or afterwards.
And similarly in the chat, there was a question that said, our building has an existing diesel engine used for a fire pump for the past 25 years. Are we required to submit a new application for certification? Again, if your fire pump has a permit to operate, then you wouldn't have to resubmit anything new. This is applicable to new and modified equipment. But if you are operating an engine that does not have an air district permit to operate, better get that application in quick because it will apply after December 2nd.
Let's see, Nick, it says you want to answer this live. Is this for new construction only, or will this require retrofitting existing generators?
It applies to new and modified engines. So if you are retrofitting an existing engine that has a permit, it depends if you're going to trigger what's called or be defined as a modified engine. So if you're increasing the power rating or increasing emissions with the retrofit, then this would apply. But this is a good reminder that prior to installing equipment that requires a permit, you should submit an application and get authority to construct from us. We have a two-step permitting process. Authority to construct allows you to construct, install equipment, and permit to operate allows you to operate equipment. And the intention behind that is to prevent costly re-engineering. So unfortunately, we have had examples where facilities put in equipment without an authority to construct, submit the application after the fact or in the middle of construction, find out that it doesn't comply with either our BACT regulation, with federal regulation, or California regulation, and they'd had to make changes. We've had instances where they had to put on abatement. Unfortunately, keep the engine, but they can do add-on abatement. It's expensive, but less costly than doing a wholesale engine replacement, which has happened in other instances. And this increases costs, it increases delays. So we always recommend that unless you know that you mean an exemption, if you have equipment that emits air pollution that's not exempt or excluded, please submit an application prior to purchasing the equipment. That way, if you do need to make some design changes or switch to a different vendor, you can do so, and then that you have the authority to construct in hand prior to constructing or installing the equipment.
We have one hand raised. Bill Winchester, could you unmute? And if you're comfortable, could you let us know what your affiliation is?
Yes, my name is Bill Winchester. I'm with Montrose Environmental. I just have a quick question about the HRA streamlining table that we were going over earlier. I just want to make sure I'm reading this correctly, and maybe I'm just misunderstanding it. But it appears that there would be no health risk assessment required in cases where you're less than 100 feet to a receptor. My interpretation of this is that maybe the no health risk assessment is actually flipped to the wrong side of the table. You know, that the closer you are to the receptor, that you would not be triggering health risk assessment versus a streamlined health risk assessment. So perhaps it's 800 plus feet that you would have no health risk assessment with those hours? Maybe I'm misinterpreting this.
No, this is, so the intention of this is to know what limitations you'll need to accept. And so on the left-hand side, there isn't, regardless of hours of use, if you comply with the 9.8 rule, hours of use, if you're less than 100 horsepower, there is no restriction other than 9.8. You won't trigger health risk. If you're within 100 feet and you're larger than 100 horsepower, then you do need to have more restrictions on hours of use than 9.8 to not trigger health risk. Otherwise, you'll be a streamlined health risk. So if you're within 100 feet and you're 150 horsepower, you'll have to accept a 45 hours per use limit. If you want the full 50 hours per year in 9.8, then it will be a streamlined. So this is just to
Oh.
identify.
Yeah, let me clarify that just a little bit, Nick. So if you are at 100 feet, and let's just take a look at the 100 to 175 horsepower range. Let's say you've got a 120 horsepower engine. If you are proposing to operate that engine at the maximum allowable rate, which is 50 hours per year for reliability related testing, you will require a refined health risk assessment. So anything that is not shown on this table will require the refined health risk assessment. So if you were at 50 hours per year, you would require a refined health risk assessment. If the project was less than 100 feet from a receptor. If you limit that operating time to 45 hours per year, then you would avoid a health risk assessment altogether. If you are at 100 to 200 feet from the receptor for that same engine, 50 horsepower, 50 hours per year of operating time for a 120 horsepower engine would qualify for streamlining. But for a larger engine, at that same distance, if you go down one row, then if you were at 50 hours, you would require a fine health risk assessment. So the option here is either you meet this level or you require a refined health risk assessment. So whatever the green or the blue, if you are operating more than those hours, it's not a streamlined health risk assessment for the less than 100 feet. It's a refined health risk assessment. And then when you're in the blue, the option is either a streamlined health risk assessment or a refined health risk assessment if you're operating over those hours. Does that
And Carol,
Bill?
I think so. What about if you were 100 to 299 feet, greater than 100 horsepower? Are you basically saying that? I guess I don't understand why you'd have to go through streamlined in one case when you're further away from that receptor than less than 100 feet.
oh, so you'd be over 40. You would need the streamlined if you were over 45 hours of testing.
No, you would require
Right.
a fine health risk assessment if you're over.
Oh
40.
yeah, that's what I meant, over 45 hours per year.
So if you're operating an engine at 50 hours per year, and you're between that 100 to 175, if your distance to the receptor is less than 100 feet, and you're at 50 hours per year, you would require a refined health risk assessment. If you were at 100 to 299 feet or greater at 50 hours per year, you could qualify for a streamlined health risk assessment.
Nick, maybe you could flip to the more comprehensive one because it might show it a little bit. And Carol, really quickly, well, I just want to do a time check. It's already 2:08. I think we could stay on for like another 15 minutes because there's so many questions, but we'll probably have to cap it at that. So yeah, real quick, Carol, someone asked, what's the difference between streamlined and a full risk assessment? So maybe you could cover that quickly.
So
as well.
a streamlined health risk assessment follows procedures that we've already determined that if these engines will meet the project health risk limits. So if the engine qualifies for TBACT, you get a project health risk limit of 6 in a million if you are within an overburdened community, or 10 in a million if you are greater than that. And our streamlined procedures take those higher levels into account. So TBACT is triggered for the engine at 1 in a million. And once you've triggered TBACT and determined that you're meeting TBACT, then you get a higher project risk limit for the application. And like I said, those are 6 in a million for overburdened communities, 10 in a million for not. And so the streamlining procedures take all that into account, and we've determined emission rates that would qualify for those engines under those given circumstances.
And so timing for a full HRIA depends on how many are waiting for HRAs in front of you.
How many requests are in front? And so the full health risk assessment includes a full air dispersion modeling run to determine what the impacts would be. It typically requires at least a couple of weeks once we start it, and depending on how many requests are in the queue, how long it would take to do that. But it's a much more site-specific and detailed analysis.
And also depending on the results, right? There might be things that need to be worked out later.
If it doesn't meet the project risk limits, then you would have to undergo further project modifications.
Let's go to another raised hand. Bob Shepard, I'm going to allow you to talk. If you can lower your hand and ask your question.
Hi, Bob Shepard with Plan. I'm not sure if I misunderstood what you had said. It sounded like you were thinking that if you put the emergency engine in a Tier 4 final certified application, if you put it in inducement override, that you wouldn't have any problems with it derating. The override is only on the SCR system. It does not affect anything. So if your DPF sensor has a problem, if you have a short in that system, if you have a DPF plugged, it's going to derate. And that would not be acceptable under the new NFPA 110 guidelines. It's just a comment, but I thought I heard you say that it seemed to be not a problem if you put it into override.
Yeah, I don't know if you have more feedback on the specifics, if they're engine manufacturers. So,
Well, I work for an engine manufacturer for Caterpillar, and the inducement is strictly for the SCR only. When you put it into that override, it will go 120 hours. If the SCR system has any problem with it, it will override that. But in the interim, and then after that 120 hours, if it does have a problem, it goes, and by the way, the NOx system still works during that override. It doesn't take it out of service. It continues to operate like that. But if it comes back on after 120 hours and there is a problem with the SCR, it would also shut the derate and shut the engine. But all along this whole time, only the SCR is affected by that override. The DPF system is not affected with an override, so it can derate or shut down in the case of a fault code on the DPF system.
And does the federal regulations require the inducement for non-SCR for NOx? It seemed like what I could find was
Most
for,
systems have SCR systems on the tier 4 final. So I'm not sure what the question is.
meaning the federal regulation appears to only require inducements for NOx related SCR issues, not for DPF. So the override feature only addresses inducements related to the SCR. And my question would be,
Oh, but there are inducements on any parts of the emissions controls. They're there for both the particulate as well as the NOx. But that's what the EPA is saying is, yes, we're only looking at the inducements being overridden for the SCR. They are not overridden for the DPF. So you could still have a problem.
and does the EPA require inducements for the TPF, or is that a
It
manufacturer?
does. It does.
Thank you.
You're welcome.
Let's take one more question with a raised hand. Joe, let me allow you to talk for a sec. Go ahead, Joe. Joe, are you still there? Okay. Let's go. Are there any more
Go to Q&A.
questions in the Q&A?
Well, Nick had marked that he wanted to answer some live, so I can't take them over, so I'll let him answer those.
I know, I think that was
Oh,
invert.
okay, so for new and modified, so this is just if you replace an engine, that's considered a new source for our rule. So it doesn't even have to be an engine, it's any kind of source. So if you replace the source, that's considered a new source, and it would be subject to new source review, which is subject to BACT. I'm trying to answer a lot of these questions in one shot. So BACT is on a per pollutant basis. So, you know, for a lot of these smaller engines, I'm not even sure they're triggering BACT. So Nick, do you want to address some of the kind of what you're where they trigger BACT?
Yeah, I think for Tier 4, they'll still trigger back. For NOx, closer to the 1,000 horsepower range. They will trigger back for carbon monoxide at all size ranges. But that's just a function of that the Tier 1, 2, 3, and 4 for CO are the same level. So they'll trigger back for CO, and then they'll trigger back for NOx in certain installations. For Tier 4, if you come in Tier 2, Tier 3, they'll certainly trigger back for NOx, CO, and in some cases for PM.
Let me see some common ones. Oh, will the small to medium compliant systems need to test every 3 years like the large compliant systems?
At this point, if you're triggered TBAC for PM and you use something other than a CARB verified diesel particulate filter, so engine modification, exhaust gas recirculation, a non-CARB verified DPF to meet that PM standard, we're proposing an initial source test. But certainly that may change in the future depending on if there are a large number of engines that are not meeting that PM or triggering this source test.
What are anticipated timelines to receive an AC and a permit to operate?
That depends on the application. If it triggers a health risk assessment, it triggers public notice. If it triggers those, the regulation outlines that we have 180 days, so 6 months. But that also depends on the responsiveness and the completeness of the application. So if we have examples of facilities submitting very incomplete applications and then not being responsive to information requests, and then having a non-compliant engine, so they'll have to make changes. And so that can certainly drag out the process. But if you come in, the fastest permit application is if you come in with a complete application through MyAir Online, certified Tier 4, you either don't trigger health risk or you don't trigger, you're subject to streamlining and you don't trigger public notice. And that'll be certainly a faster turnaround time than if you did trigger an HRA or public notice.
So let's see, it's 2:20. So Nick, I think your email is on the webinar notice, right? So you will accept some of these. Right, we'll keep these questions, see if we could group them, and maybe post responses to common questions when we post the webinar slides and the recording. So I'd like to thank everybody for coming. Next time we'll have to plan for a longer one. I see there's lots of questions. So, anybody want to cover anything quickly that they've seen? Otherwise, we can wrap up. All right, I think there's just too many here. So we'll go through them and then we'll post an FAQ on there. So thank you for coming, and it takes a few days to post. So just give it a few days to post, and then responses to the questions and answers may take a little bit longer. Again, December 2nd. Thank you.